Hey there, everyone. I haven't done one of these in a while, but I'd like to get back into the habit of doing weather briefings, especially since I really enjoy forecasting. So I'm probably going to be a bit rusty now, but so bear with me. But yeah, I really enjoy this, and I will probably have a little bit more free time this summer, which is much needed. So yeah, I just enjoy these, doing them. Current water vapor imagery, mid-level water vapor imagery. This is, I guess, 6.9 microns, so we're looking at the mid-levels, mid-troposphere. Really two features of interest. Here's subtropical storm Alberto. It just kind of seems like a mess. Looks pretty, but definitely a lot of extratropical characteristics. It's bringing some showers and thunderstorms to Florida and parts of the southeast. And then there's this other shortwave trough centered over, I guess that's Nevada into western Utah. That's setting the stage for showers and thunderstorms. Set stage today for showers and storms over high plains into Wyoming and Colorado, and a couple of which were actually tornadic. Pretty impressive storm just to the north of Cheyenne that really just cycled and produced, I believe, a few tornadoes. Unfortunately, a chaser, got injured, so that's never good to see. But yeah, these storms, for the most part, look like they were over relatively open country, which is always good news. Yeah, now things just look to have grown fairly upscale, which I'll show you in just a second. Something else, I guess I'll talk about that in a minute about the flooding, but current radar picture, this is just kind of the evolution of those showers and storms. Quite a few supercells, but now they were earlier in the day, but now they're just kind of a cluster, multicellular convection right now across far northeastern Colorado into Nebraska and South Dakota. Um, and I guess kind of how this evolves throughout the night will definitely set the stage for what happens tomorrow in terms of severe weather across the high plains, across the central and southern Great Plains. You can see these little outflow boundary kicked off by this particularly nasty cell about to move into far southwestern Nebraska. So outflow boundaries, remnant outflow boundaries, could definitely be a key point of interest the next day for any convection that initiates along the outflow boundary that manages to anchor to that boundary, stretching the vertical vorticity, and you get non-supercellular tornadoes even in the presence of fairly weak deep layer shear. Um, yeah, this is, oops, my tabs got broken there. Yeah, this is just a current loop. You can see the showers and storms from Alberto, impacting Georgia, South Carolina, and Alabama, and Tennessee. Looks like some convection over Virginia, pushing it off into the kind of the Delmarva region. Yeah, this western suburbs of Baltimore just got destroyed today. A lot of floodings, thunderstorms just training over the same area. That's what training is, just by definition. But yeah, just dumping a lot of rain, short amount of time, and just continuous back building over. I think it's Ellicott City is where it was. Yeah, and these were fairly efficient rainfall producers too. A lot of I won't get into like dual pole stuff, but yeah, it was not good to see, especially considering what happened 2 years ago, and this is the exact same area. And this year it actually looked a lot worse um, than the case 2 years ago. So unfortunately, I hope everyone's okay, and I'm just send your thoughts up to them tonight, and yeah, just keep them in your thoughts. Current surface observations here across the central and southern plains. Dew points mainly in the mid to upper 60s to a few low 70 dew points here across Texas and Oklahoma. Kind of a weak dryline feature, maybe almost a secondary dryline feature further west across central and eastern New Mexico, but the main dryline looks to be across the western Texas Panhandle and the far eastern New Mexico. And kind of generally an upslope flow regime here, especially as you make your way further west in the Panhandle, where there's a little bit of a greater topography gradient. So upslope, another source for ascent. So we'll have to keep that in mind for tomorrow. But generally, across the central and southern plains, fairly quiet with the exception of a few storms ongoing in the Panhandle right now. Current soundings, just to take a look at this. This is the Norman sounding, so deep layer shear is just not great. Obviously, kind of it's been a trend of what we've been seeing all season long, really. But yeah, large buoyancy, dew point 69 degrees at the surface there, and mid-level lapse rates aren't particularly steep. that might improve a little bit into tomorrow. I didn't pull up low-level water vapor imagery, but it's good for really tracking progression of elevated mixed layers as you get those steep mid-level lapse rates or surface-based mixed layers being advected off the higher terrain and superimposed atop low-level moisture further east. This is Amarillo, and you can really see, looks like maybe got trained into an anvil or sounding got interacted with the thunderstorm in a not so friendly way. Yeah, varying wind profile. There's that somewhat deep upslope, actually fairly strong flow. Definitely stronger flow in the mid levels and upper levels than what we saw at Norman. And, so deep layer shear further west at Amarillo is actually pretty impressive. That's what effective bulk wind difference of, it's not even, yeah, not considering it. 0.6 kilometer shear, 45 knots. So that's probably the best shear we've seen in quite some time here, this far south at least. And we could expect those the flow to increase further east, especially tomorrow, as that shortwave trough that I showed you tracks further east. Let's see, what else? I don't know, I guess we'll just talk about source regions. Yeah, I don't think moisture is going to be a problem tomorrow, especially in the area of concern, which is going to be high plains, Texas Panhandle, and western Kansas, maybe extreme eastern Colorado. That's kind of where I'm focusing on or deciding to focus on for the video. This is the Corpus Christi sounding, so moisture not really an issue upstream. Low 70 dew points, go down to Brownsville, as we saw also. 70 degree dew point there. Kind of typical of what we'd see late spring, getting deeper in the warm season, and moisture is becoming more ubiquitous, or ubiquitous, I should say. I don't know, just for fun, we'll look at the Denver sounding. Yeah, probably another thunderstorm. Something happened there with the sounding at 0Z in Denver, but let's see, what else do we want to look at? Oh, I guess we can show the this Daedalus sounding, kind of give an idea of the environment, representative at the time of all the flash flooding west of Baltimore. Deep moisture, 1.77 inches of precipitable water, so I'd imagine if you pull up SPC sounding climatology, that's probably like closing in on the daily max precipitable water. So just deep tropospheric moisture, skinny Cape profile, fairly weak flow aloft, mean cloud layer flow. So that would imply just a relatively weak storm motion. So that increases your precipitation duration, which is not good. And of course you get fairly deep warm cloud depths. So this one, let's see, tonight up to 600 millibars roughly. So enhancing warm rain processes, a lot of collision coalescence, and driving up your precipitation efficiency. So a really good flooding setup, but not a good setup overall. Let's see, GFS has kind of been wonky past few days, something with the land parameterization. I don't know how it works exactly. I'm not really big and I don't know that much about NWP, but I'm going to use the Euro. This is the 12Z Euro, so this is from this morning, just to kind of give a brief rundown of overall synoptic pattern that I already talked about, looking at water vapor, but here it is. There's that shortwave trough centered over Nevada and Utah, and then Alberto off the coast of Florida. This is tracked northward, I believe, with time, but then there's that mid-level ridge. It's going to get hot end of the week. Ridge kind of builds. It's like what, 590, 591, 594 decameter heights over Oklahoma. That's hot, anomalously high heights for this time of year, and it's probably, yeah, we're probably going to see some triple digits, maybe in Norman, but definitely across western Oklahoma into Texas. It's going to be hot. It's going to be humid, especially here in Oklahoma, and not exactly looking forward to it. So hopefully we can get some moisture, but I'm not fairly optimistic into tomorrow, at least here in Norman. This is just the 0Z NAM, so this is more of a current model run, but yeah, so there's that shortwave trough ejecting east. So you can see there's, I mean, that's what, the 45 knot flow at 250 over eastern New Mexico, Texas Panhandle. That's, I mean, it's marginally supportive probably for supercells like deep layer shear wise, but still not that strong, but it's better than anything we've seen all year. Zooming in to the southern Great Plains, is where I'm going to be focusing on. Let's just pull up vorticity. get an idea of QG forcing for ascent into tomorrow. Here's 18Z Monday. Really not much vorticity advection. Granted, we want to consider differential vorticity advection if you're diagnosing ascent. So I'll go down to 700 after this to get a sense of whether or not that vorticity advection increases or decreases with height. But I mean, not great. I mean, you expect the geostrophic wind to be roughly parallel to the isohypses, and they're spaced fairly far apart, so that implies the flow is not that strong, which is what we saw in the IsoTAC analysis as well. So just based off this, I wouldn't expect QG forcing to ascent to be particularly strong over the Texas panhandles. Maybe stronger further west or further north over western Kansas. You approach the I-70 corridor there, but and looks like there's also some convective feedback with these enhancements in vorticity there. Let's see, what else do we want to look at? Yeah, let's go down to 700. Yeah, I mean, so it looks like it might actually decrease a little bit with height over the Texas Panhandle. So that would imply subsidence or QG forcing for descent, considering that vorticity advection decreases with height. So that might not be favorable, especially when considering lift along the dry line. Sometimes QG and synoptic scale ascent can really set the stage for convection initiation, whereas the mesoscale forcing for ascent really is what initiates convection. You need much stronger forcing occurring over smaller timescales. Let's see, low-level jet, 850, it's probably too high for low-level jet. We'll go 925. Yeah, a little bit of one tonight, that southeasterly flow, and then yeah, 30 knots, so actually fairly significant across western Oklahoma. But considering the dry line, this is tomorrow. You can see there's maybe a little bit of a dry line bulge poking into extreme southeastern Colorado and western Kansas, so that might provide some greater lift, I should say, I guess, to the north of the bulge, combined with that QG forcing for ascent. So maybe that's the place to go if you're looking at chasing. And as we saw, let's see, looking at deep layer shear, let's go back. Bulk shear, we'll do that. Yeah, shear vectors are kind of oriented 45 degrees parallel to the dry line, or yeah, 45 degrees relative to the dry line, and combined with that stronger forcing for ascent up in Kansas. So that might mean more of a messy mode, so kind of a quasi semi-discrete, so clusters, that's kind of what I would anticipate. So more of a linear mode as things grow upscale with time, especially as that low-level jet kicks in. I don't know, let's pull up a forecast sounding. I'll cherry pick. Waiting for it. Yeah, I mean, that looks very inverted V-like. Storm relative felicity is awful, especially low-level SRH. So this would tell me more of a dry microburst threat when you get that low-level dry air. Yeah, I'm not terribly excited. So I'd say maybe a few storms. Some of them will be probably linear, probably severe, steep mid-level lapse rates as you saw. So hail will probably be a large threat. But overall, I'm not terribly excited in terms of severe weather tomorrow. That's really all I have. I kind of did the forecasting part quickly. I prefer more observations. But yeah, thank you for watching, and I'll try and do one of these again soon.